Guys and girls, it's Know It Time!
So before I start your applications, today's lesson is on applications. Before you can understand applications, you're going to need to know how to do the basic setups. And I'm going to go over the quiz first. This is going to be a preview to applications. Because application is all based on this stuff. It says this. There's a graph. The minimum point was pi by 4, comma, negative 2. Max point 3 pi by 4, comma 4. And I said the best way to do this is draw a rough sketch. So guys and girls, go ahead, draw a rough sketch of this right now. So I'm going to just do a quick rough sketch. Keep it simple, nothing too bad yet. Pi by 4, negative 2. I played a guessing game. I don't need to be absolutely accurate. And I'm going to say this is negative 2. Okay? Just a random wild guess. 3 pi by 4. I'm going to say here, comma 4. And this is going to be 4. Again, 1, 2, 3. 1, 2. I'm going to say this is my thing. My graph has to go only one way. See, if I'm giving you minimum, I go up, 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 until I reach maximum. And you can probably predict what happens after it goes maximum. It goes all the way back down. Because there's only one way it can go. And if I drill this very nice curve, hey, look at this. It's an upside down curve graph. Sorry, close graph. Now, the key really is the center line. Here's the center line. This is a key. When you're given any question, you got to focus on the center line. Okay. My highest point is a 4. First thing you're going to do is find the center line. This is my point in vertical displacement. So you add the two together, divided by 2, and you should have 1. So my vertical displacement is up 1, or some people just like to have 1. Okay, keep it simple. Once you have your vertical displacement, you know your amplitude right off the bat. 3. Because from 1 to 4, that's 3 units away. Here is the fun part. A lot of students always ask me, what's my phase shift? And I always tell them, I can't answer that for you. You have to choose a starting point. Everyone's going to start at a different position. For example, if I start here, I'm going to write down co-starts here. Co-starts. Okay? Because a lot of kids ask me, what's my phase shift? And I always turn them away and said, I don't know your phase shift. You have to tell me where you start from. If I don't know where you're starting from, I won't know your phase shift. See, this is where my co-starts from. So my phase shift is where it starts from. Pi by 4 to the right. No. Negative pi by 4 would mean to the left. But if you do pi by 4 and you put right, that's fine. But when you write your equation, it would be negative. It's kind of twisted that way. Okay. Now, here is the part where a lot of kids have trouble with. I need you to write down these special formulas. 1. How to get endpoint. Endpoint is given by this formula. It's your first point plus period. Okay? That's the endpoint formula. But to get period, there's 2 formulas for period, really. One is you take your endpoint minus starting point. Okay? You need to know these formulas. Question? Up. There we go. So guys, bubble these formulas right now. So endpoint can be given by first plus period, or your period can be found by taking your endpoint minus your starting. The problem with this is I don't know where my ending is. See? My ending is somewhere here, but I don't know the x coordinate to it. I only know halfway. So we'll just highlight halfway for now. I only know the distance from here to here. So why don't we minus those two coordinates right now? 3 pi by 4 minus pi by 4. So I'm just going to minus them. That would give me half a period. So that gives me 2 pi by 4. Let's just double check. 2 pi by 4, which gives me pi by 2. See, this is half period only because it's halfway. So my period is going to be pi by 2 times 2, which is pi. That's your period. So I know my period now is pi. I'm going to write this in. Period is pi. I have every piece of information I need to create my equation. So guys, let's create a cos equation now based on all that information. So your cos equation can be, one of them can be this: y equals to 3, negative 3 cos 2. Be careful, that's a 2 because your period is pi, so your b value has to be 2. Theta minus pi by 4 plus 1. Some students say, Mr. No, I don't really need to start here, do I? The answer is no. You can start here also. Watch what another answer can have for cos. If you like, you can say y equals to 3 cos. Everything stays the same. 2 theta minus 3 pi by 4 plus 1. If you want, you can start right here. It works perfectly fine. No issues. See, look, there's many different answers, so I can't say there's only one right answer. It depends where you want to start from. My sine. The question is, where does sine start? Well, sine has to start right here. That's sine starting position. I'm going to write down.
Where do you get the 2 from?
Give me 1 second. Sine starts here.
If your period equals pi, your period is equal to 2 pi divided by your b value.
So there's a formula. To get 2, I go p equals to 2 pi over b, remember. I know my period is pi. So I go pi equals to 2 pi over b. Cross multiplying b will be 2. Okay. That's where 2 came from. So guys, if I want to know what this starting point for sine is, I add these two together and I divide it by 2. Pi by 4 plus 3 pi by 4, that's pi. So would you agree this is pi by 2? Yep. So there's my sine start. I don't even have to look at the amplitude. I know everything stays the same. Okay? Save yourself a lot of time. So I know my sine will be y equals to 3 sine. See, I don't need to look at my amplitude or anything. I just copy straight up from my cos graph. 2 theta minus pi by 2 plus 1. Everything stays the same. Only thing that really changes is my phase shift. Okay? If you want, you can try to work backwards and figure out where this starts from. Does this really start at 0? I don't know yet. I have to do the math to figure out where it starts from. Working backwards is a bit more tricky because you got to do extra math. Forward is a lot easier because I'm giving the points. 1 right here, because that's where your center line is. Because you always start with the vertical displacement. That's the key.
Also, you have to like.
You have to draw your vertical displacement line to figure out the whole answer.
So if the question was they're both minimums.
Yep. No,
The sign.
then you, if it's both minimum, so we know it goes up somewhere and then goes down again. Question, Monica.
So the sine start always has to be in like cos thing.
A sine starts at the center line. So see, I can't start here for sine.
But you can't start like.
I can't start up here because that's a co-starting.
You can't just make your own.
Oh, so you're saying, hey, mister, let's just add in my extra line here?
Can't do that.
You could, but the problem is,
It's harder.
it's harder because you don't know what the exact coordinate of this is. Because you don't know how much is back here. But if I work forward, I can find this coordinate by just adding these two together and dividing by 2. Okay? So you can start here too, but it's a bit more tricky. So I can't say where the starting point for sine is. That's why when a lot of people ask me, what's your phase shift? I said, I have no idea. Because I don't know where you're starting from. If you put a starting position, say, Mr. No, I'm starting here, then I can answer your question for you. Okay? So everybody's answer will be different. But it all depends on your phase shift. Monica, question.
We have extra practice.
Extra practice worksheet. I will give you extra for this. But when you do word problems, it will make it more clear because we're going to start word problems right now. Guys, gals, it's Noah time. This is where your true lesson starts for today. 1, 2, 3, 4, 5. Here is because a lot of people ask me to know why. Why am I here learning trig? I can be here doing logs, which sounds a lot more fun. I can calculate earthquakes and pH for you. But why trig? Now, trig is really good if you're planning to go into engineering. Okay. If you're planning to go into engineering route, this is trig is heavy-duty trigs in engineering. I'm going to show you an example of one question. To do word problems, there's basically 2 types of word problems. I'm going to deal with type 1 first, and then type 2 after lunch, and then you're going to get some time to practice it. 2 types of word problems. Hard and super hard. No, 2 types. Okay. One I call is number 1. I call this standard. Standard means they all follow the same idea. Okay. I teach you one format. It applies to every single word problem. 2. The second one's a bit more tricky. This one, a lot of kids had trouble with. I call this problem seaport. 2 types. I'm going to deal with the standard before lunch and then seaport after. But before I do, I'm going to introduce the concept of something called max versus min point. Y equals to negative 3 sine 2 pi theta plus, sorry, not plus, minus 3 plus 4. I'm going to ask you find max point and min point. Max point is what's the highest point on this graph. Min point is what's the lowest. I'm going to pause it and let you have some. Alright, here we go. Max and min. In order for you to do this question, just draw a rough sketch out. I don't need any perfect sketch, I just need a quick sketch.
What do you mean a sketch? What do you mean a
Sketch
sketch?
of a graph.
But you don't need a sketch for max and min, do you?
Well, not really. But I'm going to show you anyway. See, your vertical displacement is 4. Keep it simple. My highest will be this point up here, 7. And this is 1. So my max is 7. My min is 1. That's what max and min is. It tells you what is the highest point you can go, what is the lowest point you can go. You're going to need to know this concept when you work with word problems. I'm going to start with the simple type of word problem, and this is called standard. There's many forms of standard one. The first classic one is a Ferris wheel. How many of you been to Playland before? And there's this Ferris wheel that goes round and round, and it looks something like this. Ferris wheel. That's a Ferris wheel.
You actually Googled it?
Oh, I did Google it for you guys. So this is a Ferris wheel. Ever since I was a kid, I've always wanted to go on this, but I never had a chance to go on it. Seriously. I have never.
So sick. It's like a good view of the top too.
So
Right when you're at the top, right? You can see the view of Vancouver. It's so sick. You and your hot date can sit up there.
I know. I just need to find someone to go up here, and that's Ferris wheel. See, I couldn't go before. So it goes around and round and round. Guys, don't make fun of Grumpy. So it goes round and round, and all this is you and your special friend sit on here, and during nighttime go up, and then you go down. Okay? You and your special friend, whoever that is. So, what it is go in circles.
Oliver's been there.
Here's your question. Okay? A Ferris wheel. A Ferris wheel has a radius of, let's say this Ferris wheel is pretty large, maybe 20 meters. 20 meters. Classic Playland Ferris wheel. And if you've ever been to Ferris Playland, there's actually a video. It shows you what it looks like. So here it is. Wow, it's all ready to go. So Jez meets here. Oh, hang on.
So we are now on the Ferris wheel.
So this is the Ferris wheel from Playland. There. So guys, that was a view from Ferris wheel. No. It's actually a clip I found on YouTube, and it is you go up and you go around in circles. So this Ferris wheel has a radius of 20 meters. Okay. And it also tells you that the lowest point is 2 meters above the ground. Because the Ferris wheel can't touch the ground or else you scrape it and people start falling off. It's 2 meters above the ground. It takes, so let's say you ask the rider to slow down this Ferris wheel for you and your special friend to enjoy the view up there. Maybe 70 seconds for the wheel to make one complete rotation. To make one rotation. Okay. Here's your first question. The question will say create. Oops, sorry, I gotta add one more thing. Let's say just meet. Gets on the wheel with his mom. Oh, you're too young. Just me. You're too young to go under yourself. You need your mom here. Gets on the wheel. At the lowest position. Because you can't really get on at when it's in midair. At the lowest position. You could if you want. They're going to say create a sinusoidal equation for this. Sinusoidal. Here's the word of the day. Sinusoidal. When a lot of students see this word sinusoidal, they think of sine. Sinusoidal really means sine and cos equation. Okay? So when you see this word sinusoidal, what it means is, I want you to create a sine and cos equation. Because sinusoidal means it could be sine or cos. It's not just sine graph. Create a sinusoidal equation for this wheel. I'm going to help you out since this is the first time you're doing this, and then I'm going to give you a chance to do this on your own. The best way to do this right now is to draw out my diagram. I'm going to show you. So let's draw out the Ferris wheel right now. Here's my Ferris wheel. Okay. Let's say this is the ground right here. And let's draw just meet. And here's his mom holding his hand.
Draw a round thing on my head.
You can do that on your own. Now, we know the lowest position is 2. Because I told you that the lowest point this first wheel is 2. Guys, gals, you got to figure out what is the highest position this Ferris wheel hits. Think about it. 42? Why 42? So here's another key. Here's another word you need to look at. The radius is 20 meters. See, the radius means 20 meters. So this from here, to here is 20. Which means if I add another 20 to this, would you agree the highest position is 42? That's the highest position you can go. I'm giving you my lowest. I'm giving you my highest. Now, nope, because you're 2 meters from the ground already. That's where you're starting from. Okay. See, I haven't done anything hard yet. I'm just labeling my Ferris wheel and just giving you some basic numbers from using logic. Now, the key, I'm going to give you steps to success. Steps to success. These steps work for every single word problem there is. To success. Double C, double S, and you will always succeed. 1. Draw your graph. Okay. Notice I'm drawing my graph. I never said label anything yet. A lot of people make mistakes when they do word problem is they try to match the points up on the grid. That's where you're going to make errors. Question, Monica? Nope, that's not a graph. This is just a picture of Jasmeet. Okay? And his mom. Do you have a brother too, Jasmeet? Maybe you wouldn't add your brother. Oh, you have a sister. There's your whole family can be on one wheel. Oh, yeah. Your dad's going to be a bit taller. The whole family has a... So, draw your graph. 2. Now, before you draw your graph star, this is a big issue. Find where you are starting from. Every question has a starting point. Some questions say you start from the highest position. Some says you're starting from the lowest position. Some says you're starting in the middle. Okay. Find where you are starting. Find you're starting from. Read the question. Here it says this: Jasmeet gets on the wheel at the lowest position. So I'm starting at the lowest position. That's the key. Every question must tell you where it's starting from, or else you can't do it. 2. Label your axis. Okay. In my class, I like to work things backward. In other classes, they like to label the axis first and draw the graph. I find that a bit more challenging. Here, when you draw it, you get a nice idea what the graph looks like. 3. Okay. Find amplitude, vertical displacement, phase shift, period. Okay, just like what we've been working all this time. And finally, 4.
What's that?
Period, yep. Create your equation. That's it. Create your equation. These 4 steps will solve every word problem there is. So the key, I'm going to do step 1 with you. Draw a grid. Okay. So Ferris wheel, let's just draw a nice grid right now. Let's say this is my ground. Ground is here. I'm starting at the lowest position when timer, so call this 2 meters. 2. This is my starting. I shouldn't really label yet. Guys, gals, if I get on a 2, the Ferris wheel only goes one way, and that's up. So why don't we draw a graph up to some point there. We don't know where it is yet. Once it reaches the highest point, guess what happens? Comes down. See? It goes back down. That's the only possible graph you can draw. And goes back up and down again. But for now, I'm going to just do one cycle. See? My graph. Notice I didn't really label anything yet. I don't need to label where my beginning, my end is. I draw the graph first. It's easier if you draw the graph first. Now, I'm going to pause it. Let you take... Megan, what's the highest point going to be, Megan? 42. Remember my Ferris wheel? Right here, 42 is the highest point from what I just showed you. Now, I need to label my ending right here. Let's just label this ending. 70. Because it takes 70 seconds for one rotation. Guys and gals, go ahead and find amplitude, period, phase shift, and other lovely stuff. Now, the key, remember, is center line. I don't know where my center line is, so draw one right in right now. Monica, what is it at? 22. So let's go through this process right now. My vertical displacement is right there, shown for you. I'm gonna repeat. What is it? 22. Because that's the center line. Amplitude is indeed 20. Now, a lot of students ask me to know, what is my phase shift? It depends right now. Do you want to do cos first or sine first? Let's do cos first. If I'm going to do cos first, I'm going to make my life easier. I'm going to say cos starts here, which is no phase shift. Cos starts. My phase shift is 0. I'm going to work with cos first. Okay, no tricks. My period is 70. But when you write your equation, we don't use 70. We use a b value. So let's calculate b right now. Find b, which is correct. So we're going to use that formula. 70 equals to 2 pi over b. Take a minute and solve this on your own. B is pi over 35. Guys, gals, I have every piece of information I need now. Create a cos equation. Once you finish that, create your own sine equation. I'll pause it again. I'm just going to give you a thing right now. So you get y. Abraham, take a guess. What is it? Y equals to? Sorry? We're doing cos first. Y equals to? Negative 20. You forgot your negative sign. Cos pi over 35. I'm going to use x. See, x is this axis right here. Y could be this. Okay. Some people like to use theta. It's up to you. Makes no difference. Finally, Harpreet, what's the last one? Plus 22. Hey, guys, gals, that's one of them. Done. That was as easy. Nothing hard. Now, the key word here is sinusoidal. Sinusoidal means sine and cos. I found a cos equation. I want you to take your time now. Go back and find a sine equation. We know sine is almost the exact same thing. Only thing that changes is the phase shift. On your graph, put a dot where you want sine to start from right now. Okay? You want it right here or right here? It's up to you. It doesn't really matter. Let's put a dot right there. I want my sine to start here. Sine starts here, for example. Okay? That's where I want it to start from. I want you to find out what is this coordinate going to be. 17.5. Okay. Think you're going to keep on. So which is 17.5? To find this, remember we find the midpoint of this, which is 35. And then midpoint again. This is why you need to know the midpoint formula, because it's all based on symmetry. So y, I don't have to think about it now. 2 sine, everything stays the same. 20. Pi by 35, x minus 17.5 plus 22. Once you find one equation, getting the other equation is very quick and simple. Guys and gals, Ferris wheel. Hi. Question. Sorry? It depends on what shape it is. That's why you got to draw. I'm going to give you another question right now. Guys and gals, try this question your own without my help. Question, sorry. What shape is this? That's a negative cos graph. Because the cos graph starts up. Okay? Good question. Try this one, guys. Another question on your own. A Ferris wheel has a diameter that's after lunch. I just want you to set up your equation first before I murder you. A Ferris wheel has a diameter of 30 meter. What? Of 30 meter. Okay. The center of the wheel is 16 meters above the ground. A person, let's say this Ferris wheel is unique because you get on at the highest point this time. Okay. Gets on at the highest point. So instead of getting on at the ground, this Ferris wheel is unique because you get on at the highest point.
So you have to climb the stairs.
Yep. You're gonna enjoy the scenery while you're up there waiting to get on.
It's pretty cool.
At the highest point. Okay. Create. Sorry. I just take a Ferris wheel and build some ladders. Go up. Create a sinusoidal equation. Again, there's that word sinusoidal. If you just give me one equation, you know you're going to lose marks. Oh, yeah. Create a sinusoidal equation. I forgot. It takes 20 seconds for the wheel to go from highest to lowest. To go from highest. That's where you figure out. Highest to lowest. Guys, gals, another classic exam question. Good luck. I'm going to pause it and let you figure. If you're stuck, just draw the first wheel. Doot. Here's my center right here. Okay, if you're stuck, the key, here's the center. The center is 16 meters above the ground from here all the way to here. That's what it says. If this is 15, has to be 1 meter right here, 1 meter. So the lowest position is 1 meter. Now, find the highest position, which is 31 meter. Once you have that basic understanding, go ahead and draw your sine graph or cos graph right now. And remember, every question tells you where you're starting from. If it doesn't, you can't do it. So my first wheel is unique. You get on at the highest point. That's your key. Okay. So again, just draw a rough sketch. Very quick. Nothing too tricky. And then after this, I'm going to show you how to apply this using your graphing calculator. I'm getting on somewhere at the highest points up here. We'll call that the highest points. Sorry, I should draw this. The ground's down here somewhere. Okay. And there's only one shape you can make it. If you get on the highest point, it has to go down. And you cannot touch the ground or else the Ferris wheel breaks. So you go up, 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 up. There's your curve. Guys, gals, label the curve now. Take your time. I'm going to pause it. This is 1, and this is 31. Find halfway. 16. Okay. Now, this is 20. I'm just making labels right now. I'm going to go ahead and find all the key things. I know my vertical displacement is 16. Amplitude is 15. 15.
Wait, where'd you get the 1 from?
1? Because the lowest point on the Ferris wheel has to be 1. Because the center is 16. Center is 16, right? And the diameter is 15 meters, so that has to be 1. So lowest position you have is 1. Okay. Period is, be careful about this one. Your period is not 20. Irish, what is your period going to be? 40. Because half, it says from high to low is 20, right? But period means for one cycle, so it has to go back up in order for you to make one period. So therefore, this point is truly your period, right here.
Go back to how you got
1?
1.
The diameter is 16 meters, agree? Sorry, no, the center is 16 meters.
Oh, so that's radius? It says the diameter is 30 meters.
Yeah, the center of the wheel is 16 meters above the ground. So this is 16 above the ground, from here to here, all the way down. Now, the radius is 15.
So 16.
Minus 15, so that gives you 1 meter gap. Okay. So guys, my b value is pi over 20. That's your b value. Yes. Finally, my phase shift, if I'm doing cos graph, there's no phase shift. 0. But there is for sine. So let's create my equation right now. Y equals to 15 cos pi by 20 theta plus 16. Guys, I'll give you 1 minute. Create your sine one right now. I pause it. This, well, if you start here, we're going to write down sine starts here. Sine starts, which is 10. Because I used the midpoint formula, which is 10. So put everything together right now, and you get y equals to negative 15 sine pi by 20 theta minus 10 plus 16. Because this point right here is between 0 and 20, agree? It's halfway. No, 0, because we're looking at the x-axis. This is 0 right here. 0, 20, because you get on when time equals to 0. Okay? Guys, gals, that's part B to this question. This is called applications now. You found the formula, but how do you apply this formula? So we are going to go back to this question about this Ferris wheel, how you're getting on at the highest position. Okay? Well, my page is infinite. Your page is not, because this page keeps on going. There's no end to it. Yep. In OneNote, you can keep on going for 1,000 pages. There's no end. It only ends when you run out of hard drive space. Here we go. So let's say I use the formula. Before we start, need to know a few things. Number one, theta. When you work with word problems, theta in this case refers to time. This is your theta. That's your time. My y refers to height. That's your time, height. So when you draw your graph, this is actually theta. Some people use x. That's your time, how long it takes, seconds. Okay? They're going to ask you a typical question, and this is why it's good for engineering. If you're planning to go to engineering, trig is really useful. They're going to ask you this. How high is the wheel? So part A. How high is the wheel at let's my pen, it's running, it's lagging. But hang on. There's just like the at. There we go. 7.3 seconds, for example. Because they want to know exactly at 7.3 seconds from the moment you get on, what is the Ferris wheel at? 15 cos theta. So guys, there's two formulas. You can choose any formula you want to work with. If I were you, I choose the easiest one to work with right now. And this is the first one. So let's write down my equation. Y equals to 15 cos pi over 20 theta plus 16. You can use any equation, you get the same answer, but for me, I like to use the one with no phase shift because it's easier to plug in. One thing you should be careful about is this. Notice there's a pi here. Right off the bat, the moment you see pi, Kavir, what are you working with, degrees or radians? Radians, good. So you're going to set your calculator. This is where people die on their exams. Your calculator has two modes, degrees, radians, and actually there's a third one, it's called gradients. So grab your calculator right now, and let's turn on our calculator. It's going to be helpful if you have a TI-83 or a graphing calculator, because you're going to plot this. If you're using a TI-83, I advise you start bringing your graphing calculator. I'm going to show you how to change your calculator into radians. Hit mode button right here. There's a mode button right now. Find the mode. Mode. Right off the bat, it brings you to the screen. Go down to radians. Make sure that radians is highlighted. Okay, there's a radians. Now here's how to change the brightness. You hit second function. Grumpy, you hit second. And you're going to hit this button, up, 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 and down. It will change the brightness for you. Okay? And hit enter. If you want to change the brightness in your TI-83, hit second function, and then press up arrow. It will change the brightness, how dark and light it is. Okay? So now, your calculator is in radians mode. So, I'm asking you, what is the height? So they want to know, what is y?
Was radius the third one?
Hit mode. It should say radians right off the bat for you. Mode. Radians right there. Third one. Highlight it and hit enter. Okay.
It didn't work, but you know.
So now, I'm looking at 7.3 seconds. Guys and gals, plug in 7.3 into the right, which one it is, and solve it for me. I'm going to pause it and let you try this on your own. Where does 7.3 go? See, 7.3 goes into theta, because that's my time, I mentioned to you. So let's plug in and solve right now. 15 cos pi over 20 times 7.3 plus 16. Okay. Now, here's the key. There's actually a bracket right here, because you're cosing the whole entire thing. So watch how I'm going to punch this in my calculator, because if you're stuck, so look up here. Okay. First thing, I want to figure out what the heck all this equals to, so I want to cos it nicely. So let's punch all this in my calculator right now. So I go 7.3 times pi, okay, divided by 20. I want to figure out what it, because I'm cosing the whole entire thing. 1.1466. So now I'm going to press the cos button, because I'm going to cos it. Cos that number 1.14668. And again, I try to use as many decimal places as I can to make my answer more accurate. Now I hit enter, because I wanted to hit what cos it is. Okay. So far so good. You should have that number right there. Now I times by 15. See, I don't enter this all in one shot. If you do, it may work, but it increases your chance of making an error. I do it nice and slow. Take your time. Times 15 plus 16. So at exactly 7.3 seconds, I am 22.17 meters above ground. So your answer, y equals to 22.17 or 0.2 is up to you, meters above ground. Okay. I'm going to get you to try one on your own just for practice. B. How high are you at 33 seconds after you get on? So let's say you're an engineer. You want to know what is the height of this wheel. 33 seconds after it spins. Guys and gals, practice using this formula. I'm going to pause it and let you have some crack at it. Oops, it's not paused yet. So if you're stuck, watch what I'm going to do. I know theta is 33 seconds. So I'm going to just plug it in. 15 times cos pi over 20 times 33 plus 16. Again, really, cos of the whole entire thing. And just keep it simple. I'm going to clear this up. If your calculator is in degree mode, you're going to get a wrong answer, and there's going to be no pity. Make sure it's in radians. 5.1836 times 15 plus 16. Hey, 22.8, really, 8.1. So, guys, pretty easy stuff. 22.81 meter. Here is where graphing calculator comes in handy. C. At what time is the wheel at 25 meters. So I'm looking for the time now. At what time is the wheel at 25 meters? There are many ways of doing this question. You can either plug it in.
Can we try it out by ourselves?
Yep, pause it. I'm gonna pause it. In this question, it's asking you for theta. So again, I go back to my formula. The formula I started with. Y equals to 15 cos pi over 20 theta plus 16. Now, I'm looking for theta this time because I'm asking you at what time. So a lot of you went, that's easy. You went 25 equals to 15 cos pi over 20 theta plus 16. Again, I try to have these in brackets. And a lot of people, what they do is to solve for this. Guys, gals, move the 16 over first and move the 15 over next. So you went 25 minus 16. Because you're going to move the 16 over first. Equals to 15 cos pi over 20 theta. Once you solve that, move the 15 over. Okay, so it'll be 9 over 15. 9 over 15. Yep. Cos pi over 20. 20 theta. Now, some of you got to this far, but you're stuck. I'm going to show you how to solve this. Take your calculator, and you go, let's clear all this up. 9 divided by 15 is 0.6. So let's write down 0.6 equals to cos, and I'm just going to leave it for now, all that stuff inside the bracket. The question is, back in grade 10, you were taught how to get rid of cos. Inverse cos. So what we're going to do is to get rid of cos, we're going to use a special function called inverse cos. Cos of negative 1, 0.6. So punch it in. Second function, cos. You should get that on your TI-83.
You got 0.927.
That's what you have. 0.6. 0.927. So let's write that down. 0.927 equals to pi theta over 20. Solve for theta. Bring the 20 over and divide it by pi. See, this took a lot of work. I don't know about you, but I don't have time to do all this work. So I'm going to show you another method to do this later. I bring the 20 over, which gives you 18.54. Now, I divide it by pi. And what you should get is 5.9 seconds. So let's write this down. So my answer is 5.9 seconds. Theta equals to 5.9 seconds. That works perfectly fine. No issues with that. But it took too long. I'm going to show you how to use your graphing calculator to graph, because you have to know how to graph on your graphing calculator. My equation I want to graph is going to be this equation right here. So if you don't have a graphing calculator, look at the neighbor beside you. So I'm going to show you how to do this right now. Grab your graphing calculator. Let's clear all this stuff up. The first thing you're going to do is somehow on your graphing calculator, you're going to try and get a shape that looks exactly like this. That's the first thing. So the first thing you're going to do is set our Windows mode. Your Windows mode is what is the highest and lowest point on your graph going to be. So under Xmin, would you agree my lowest is going to be 0? Right there. So I want you to put in 0 under your Xmin. Hit clear, whatever that number is, put in 0 right now. Oh, sorry, 0 is fine. Xmax. Take a guess what Xmax is going to be. 40. Because you want one cycle only. One cycle takes 40. If you want to put in a bit more than 40, you could. Hit clear and punch in 40. If you want 41, you can put in 41 if you want. 40. Y min. What's the lowest y coordinate you can have? 1. But I want to just, show a bit more, so I'm going to put 0. Oh, and this x scale means how much should each spacing be. So each spacing is just 1. Always leave it as 1. Now y min, some of you may put 1, it's fine. Some of you may use 0. I use 0 because I want to show that little gap. That's why. Y max.
30.
Not 30.
31.
31. Okay, we're just playing around with the Windows mode. Once you finish that, you're done with Windows mode. That's it.
How about Y scale?
Now, nope, hit y equals to next. This will bring you to this form right here. Y equals to. On your exam, they asked you to graph on your TI-83, so you have to learn how to do this. Y equals is a place where you're going to input your formula. There you're going to input up to 7 formulas at once, but for now, all we want to do is input the first formula. 15 cos pi over 20. So let's do this right now. 15. Punch in 15. Hit cos. It will have a bracket. Would you agree there's no theta here? Theta is the same thing as x. So we are going to write down pi x. There's x button right here. Find the alpha button. You could, but if you look at this, I can rewrite this as 15 cos. If you want to think of pi x over 20, agree? Plus 16, because that's what it is. So you go pi. Now the x button is right here. Hit x. That's your x button. Right here. Right beside alpha, there's an x. Okay. Hit divided by, see there's division, by 20. Now make sure you hit end bracket.
Where's the x supposed to go?
X is right beside alpha, right here. See it? Right there. Yep. Hit it. Now, hit end bracket. Hit plus 16. Once you finish that, hit enter. Or hit graph. The graph is right here. If you look at that, it should match exactly to my rough sketch. There's your nice graph. Okay. But the question is, it asks you, at what time is the wheel at 25 meters? Once you have your graph, hit y equals again for me, please. It brings you back to the screen. Under y2, I want you to plot in 25, because I want to know when it hits 25 meters. Hit 25. Okay. And hit graph right now. And it will draw a vertical line. This line represents 25 meters. So take your little arrow key, and you get a little mouse, little cursor. Move to the first intersection and see where it hits. See? I'm just right here. Just move it, and look at this. It's going to hit right around there, 5.9. There's arrow key right there. See? I didn't have to do any work. But look at this. Would you agree it hits again? What is the second point it hits at? Because there's really two answers when it hits 25 meters. Because it goes up and it goes back down again. If I look at it again and just move it over, and it'll give you a really, really nice rough estimate answer.
34.4.
About 34.4? Right about there, about 34 seconds. So my Ferris wheel hits it at 2 times. When you do if you do it mathematically, you don't get one answer. But when you graph it out, it actually shows you there are 2 times it hits the Ferris wheel. You have to write both. Okay. Sorry? Yep. 5.9. We found this B. That's what it is. Guys and gals, I'm going to get you a practice question and for you to try to plot this and graph it. Go back to your original question. Actually, I'm going to give you a brand new question. You're going to do this from scratch now. Let's say a Ferris wheel no, because I want you to practice both forms. A Ferris wheel has a radius of 25 meters. Okay. The center is 30 meters above ground. Actually, I'm going to make this my supernova question for today. I'm going to walk around. If you have the right answer, you get a card. Simple as that. The center is 30 meters above the ground. Johnny gets on at the lowest position. Simple question. It takes one minute to make 3 rotations. Okay. Create an equation for this. Good luck. There's gonna be no talking with your neighbors. I want to see who. Nope. Oh, sinusoidal. There's gonna be a sinusoidal, so I'm gonna pause it. So, few key things. Number 1, right off the bat, let's just draw a rough sketch. Okay. Remember the key. Just draw a rough sketch. Nothing too bad. Keep it simple. Now, I get on at the lowest position. See, I don't care about labeling yet. I like to draw first. I draw first, makes my life a lot easier. And a lot of you labeled this was 5 is correct. This should be 55. Right there, highest position. Halfway should be 30. Okay. Now, that's not the trick. The trick is this point right here. A lot of students put 1 minute. That's where their error lies. See, a cycle means for 1 period means for 1 cycle, but this is 3 rotations. So in reality, 3 rotations, would you agree, that's just 20 seconds right here. That's 20 seconds right there. So that's the twist. So if you put everything together, you should get these equations. Y equals to negative 25 cos pi over 10 theta plus 30. And I'm going to use brackets here to show you that I'm using cos of that whole thing. Or I can have y equals... Yep, question?
What if you put, you did 3 cycles?
Yep.
You put 1 at the end?
Yep.
Right, would you still get the same answer?
But would you get, well, what's your b value? As long as you get pi by 10 is correct.
You would put 60 at the end. You'd put 60
Yeah,
at
you
the
have
end.
to put 60, right?
Doesn't it have to be seconds? 1 minute?
Give me 1 second.
Would it have to be seconds?
No. Because your error, give me a second, I'll show you where your error lies. See, your error lies here. The concept of period is for 1 rotation. This is 1 minute for 3 rotations. That's not period. So period means 1 rotation. So which means 1 rotation is only 20 seconds. Or if you're working in minutes, it should be 1 over 3 minutes. If you work in minutes. So I didn't care what form you work it in as long as you have the b value. So guys, gals, I have 2 equations. Use this or this. Let's learn to plot this in. I want you to graph this in your TI-83. It's probably easier if you graph this first one. Question? 5? 5? This one? Here? Here? Because that's lowest position. 25 meters the radius, 30 is the center. So the bottom of the wheel has to be 5 meters from the ground. Question? Negative 25 cos. No, you need to have both forms. If you're missing one, I won't accept it because you're sinusoidal. Question? How to get to 5? To get to 5, you need to understand how the Ferris wheel works. Here's my Ferris wheel. Okay. 30 meters is the center. 30 is from here to here. Okay. But the radius is 25 meters only from here to here. So which means this bottom piece has to be 5. That's where it is. For the sign? For the sign, if this is 20, my sign, the reason why is you guys are not putting a starting position. Put a dot right here. Okay, that's the reason why. To figure out what this is, it's all based on symmetry. This is 10. This has to be 5. Okay? Question?
If you start your close graph, where's the maximum at 10, right?
Yep. Then it'll be a phase shift of 10. That's why I gave you yours was correct also. So guys, now I want you to learn how to plot this. Take a minute. I want you to plot this in your TI-83, please. First thing you're going to do, change the window. Right off the bat, you need to change the window to match this one. Question? Please. First thing, I want you to change the window right now. Hit window. Okay. And let's clear all this stuff. You got to change your graph to match up with this setting. My minimum is 0. Max is 20. Okay, no tricks. My Y min, I always like to leave it at 0. Some of you can use 5 if you like, but I like to use it at 0. Y max. See, my Y max is different now. 55. Once you finish that, hit Y equals 2. And I want you to clear all these equations. Hit clear and hit clear right now. Clear all that out. I want you to plot this in for me under Y1. Take a minute, and I'm going to come around. So guys, so watch what I'm going to do and plug it in. I go negative 25 cos pi x divided by 10 and bracket plus 30, and I hit graph. And look at that. It matches exactly like my sketch that I drew before. Okay. The reason why is they're going to say part B. At what time is the wheel B? At what time is the wheel You could, but it's more complicated. I choose the easiest graph. Is the wheel at 46 meters high? See, instead of plugging it in, once you have your graph, this makes your life a lot easier. So under y equals to, again, guys, gals, under y2, put in 46. Because I want to know exactly when does it hit. And hit graph. See, there's a little bar. That bar tells you where the 46 meter is. My graph hits it at 2 locations. Take your little arrow key and just move your little cursor. And just close as possible. And this is a rough guess. As well, 7.2 around there. Seconds. Roughly. Then there's another time. So we know there's going to be 2 answers. And just move it over. 12.78 seconds around there. Yep. On your test, it's going to be multiple choice maybe on this part. And then all you're going to do is find the quickest one. Saves you a lot of time. Okay. So guys, this is how we use our TI-83. It saves you a lot of time if you graph it correctly.
On our task, is it going to have both answers?
Yeah, it will.
Together?
Yep. Okay. That's why if you use a calculator, I'm going to end my lesson here and let you have practice with this. Every question, remember, works on the same principle as Ferris wheel. It doesn't matter if it doesn't talk about Ferris wheel. It's all the same thing. Page! We are done. Done. No, not yet. Maybe. Page, 74. 75. Number 4. Two, 10. 4 to 10. Number 1 to 3 talks about seed port problem, which I will work with you later, not yet. Sorry? Yes. They're all connected. You will have a quiz on this tomorrow. So make sure you have your TI-83 or else you're going to be in trouble tomorrow. Bring a TI-83 with you.